What's up, YouTubers and fellow builders? So today we are going to be tackling a problem, or I guess not really a problem, but a thought that's very common. And that thought is, if you preheat the plates, it will increase penetration of the weld and it will make stronger welds. Well, I know in previous testing I've done like 6-8 months ago, preheating plates absolutely increases penetration. The question is does it increase the actual strength of what you welded, so the welded joint? So that's what we're going to tackle today. Let's get into it. So right off the bat, the test setup I'm going to use is a fillet weld, and we're going to do 4 fillet welds. We're going to do 2 without preheat, and we're going to do 2 with preheat, all at the same settings. So for both voltage, wire feed, same machine, all of that will be the same. This is all 3/8 thick plate, decently thick, realistically over the ability of my machine to weld. Partially why I picked this thick of steel is because I believe the preheat will actually give us far better performance on this thick a plate over if I went smaller, like say 1/4 inch or whatever. I just believe that we're going to see a bigger difference here. And it also kind of coincides with my thought process. If your welder's too small to be welding what you need to, you got to preheat it to even stand a chance, especially on aluminum. But rather than just saying, oh yeah, it increases penetration, I thought, why not actually test this so we can have hard numbers to see how much and if it does. So that's the point of this video. Now there are a couple things I'm going to disclose right away so that we're all on the same page. One, like I said earlier, my MIG machine, I'm limited to about 200 amps of output on my generator. That's my welder, I guess, is capable of probably somewhere around 215, 220 for intermittent use, but we're going to be maxing out 200 amps. 200 amps is not enough to be safely welding 3/8 plate in a fillet weld position. It will get some penetration. I've proven that in a previous video, and it does actually make fairly strong welds for what it is. So that's interesting, I guess. The second thing I'm going to mention, I will be breaking one of each towards the face, so towards the weld, and then we will be putting 2 of them in my new shop press and breaking them away from the face, where we're going to determine how much tonnage it takes to do that. My guess is that's going to be less different than breaking it towards the face, and the reason is that higher penetration is going to favor leverage, or how do I say, reducing leverage towards the face. So in simple terms, the more penetration we see, the better the performance will be breaking it towards the face of the weld. That penetration, I think, will have far less of an effect when we're dealing with stretching the weld, where we bend it away from the face, and I think they're going to be closer with the preheat. At least that's my theory, and we'll talk about that depending on how this testing goes, because you know I'm never wrong. And no, so seriously though, we'll talk all about that at the end of this video. And for right now, I'm going to get set up and I'm going to weld all this, preheat the ones that need it, weld those, and then we're going to get to breaking them. All right, so I got all of these welded up, and it's time for a little bit of a beer break here. And by beer, I mean ginger beer. Thanks to the guy that recommended this Reeds. This stuff's pretty good. I also bought the like super strong stuff, and that made me sneeze off of one sip. So that's some pretty potent ginger beer. So anyways, let's get in and look at these a little bit closer. I wish you guys were here with me to see this in a little bit better detail than what you're going to see in this footage, but hey, it's the best I can do for you guys. So the 3 on the left are run with cold plates, the 2 on the right were run with preheated plates. Now you're probably asking yourself, well, you only welded 2, and you're correct, great memory. I had to do an extra one because this one right here, which was the first one I did, I realized that something was kind of going on. The arc was sputtering, and I went and investigated, found out I never set the roller tension above 2 out of 10, so the rollers are just slipping. Once I corrected that, I ran 2 more plates with the correct wire drive tension and had no further issues. We'll still bend brake test this, but I had to throw that one out of our results because I'm sure it will have different results than these two because the heat it was carrying as that arc cutout changed. These are more consistent. With that said, it really doesn't look visually worse or better or anything than these two, but it's just, I can't trust the results from that. So anyways, between these, right away what jumps out at me is that the preheated plate, the welds are flatter and like wetted out better. Not by a lot, but from my vantage point, they just seem wider, flatter, and when I was welding it, it seemed like I was running hotter settings, which again, I won't insult your guys' intelligence. Obviously, that's what we expected because these were preheated. The difference just visually looking at them, I guess, is a little bit more subtle than I would have expected considering how hot these plates were. They're probably, I'd say, pushing 500 degrees. But, you know, I guess, you know, we'll have to see if it affects the strength, which, let's be honest, we know that it's going to affect how strong this is because of penetration increase, but how much we won't know until we test it, which let's get set up and let's test it now. All right, let's get to breaking these. I'm going to start with the 2 that were done without preheated plates, so that extra one that's defective, which is going to be the second one, and I'll save the preheated plate for last. So we're at 100 even. That's pretty strong. All right. That actually exceeds 1/8 inch 7018 single pass weld, but this is a bigger weld than that, so that's probably why. All right, let's test this one. 91.7. That's probably within the realm of error, but like I had said, the arc was cutting out because the drive rollers are spinning due to the high wire feed speed. Well, guess what? Didn't carry as much heat on that. Did it lose strength? Compared to most of the MIG welds I've done, I would say that's on the lower end for this plate. So yeah, the possibilities there. And you know what? I'll just mention this really quick. If you're welding something and you know it needs strength and you know that there's a defect, like due to something you were doing or a machine screwed up or maybe your ground clamp didn't have good contact, you're better off grinding that sucker out and re-welding it than you are just, I guess, acting like it didn't happen and walking away. At least in my opinion. The devil's in the details. Now let's try the preheated plate and see what happens. I have a feeling this might be stronger, but we won't know. And it indeed was about 106. It already cleared itself. Cheap Harbor Freight crap. So yeah, that's the highest result I've actually seen out of MIG. So it definitely did increase the strength. However, that is in this test where penetration does matter. Let's go over and use a new shop press and bend them away from the face and see what happens. All right, so I got the 2 remaining ones here. This was welded cold, this was welded preheated, so let's start out with the cold one. All I did was grind the edge here and up here a little bit rounded so that it should hopefully flatten this out a little bit better. This isn't really a scientific test. We're just going to look at, once it starts bending, how much force it takes to bend. And more importantly, we're going to look to see if one of these is going to bend all the way flat and curl this 3/8 plate. I doubt it'll happen. It may though. These welds may have enough tensile strength to where we can flex this 3/8 plate and the weld holds. I doubt it, but we're going to see if there's a difference between these two. And in future videos, I'll be doing a lot more testing like this, and the results will be a lot different, I think, than this, simply because we're dealing with such a high tensile strength wire compared to, like, say, a 6013 or something. All right, let me get compressing this. Goes without saying, this probably isn't the safest method, but I'm keeping my dome in my eyes nowhere near this. All right, so now the point we're at, the weld is carrying the whole load of it. The plate, you could see, shifted, and I kind of set that up to where it would slide a little bit because this is trying to dig in the plate here and back there. Well, now it's past that point, and it's merely the weld strength that's holding it together. And that's why you're going to see the hydraulic level, the pressure lower, simply because it's taking less pressure. Still feels plenty strong to me. This might actually make it all the way through this test in one piece. And now we're just basically bending half of the plate, so I'll try and put a little bit more force to see if we can't tear that weld. I doubt it, though, at this point. And that's probably about as much as I care to put into it. That's quite a lot of force from my end. All right, let's let it up and bend another one. Reposition this. And I would say that's good enough. Let's go and see what we got. Well, both of these, the preheated plate as well as the non-heated plate, passed bending away from the face. I mean, for a single pass weld done with short arc MIG, which doesn't really have the greatest penetration, to have both of these pass with essentially an undersized weld. That weld is not proper size for this 3/8 plate. That's pretty cool that they both did. I would not have bet that. I didn't think either one of them would. And they're both bent exactly to the same size, and where it was at, I really couldn't bend it anymore. I mean, had I done any number of things to get this to not flatten out or not curve like this, I probably could have stretched the weld enough to break it. But I mean, for all practical purposes, this exceeded the strength I expected out of it, which is quite interesting. And this is a lot different, I guess, than bending it towards the face, because the face we can measure actual differences, but in the case of this, where the weld didn't fail per se, it's a lot harder. And that doesn't mean that you can short arc MIG 3/8 all day. Really, you shouldn't be doing that, because, well, you saw there were differences when we bent it towards the face. But not only that, over time, like, yeah, this has a tremendous amount of strength the way it is. However, if this plate was subject to vibration or continuous stress, having an undersized weld in the long run would likely crack or fail. So just certain things to think of. But let's go, and I'm going to break these the rest of the way, and we'll do a close-up look at those. So let's take a look at what we got on these where we bended them to the face. This one here was that kind of defective where it was sputtering due to poor drive roller tension. This guy in the middle was basically an okay weld, but it was done on cold plates, and this was done on hot plates, so somewhere above 400 degrees. Let's start off with this guy. So when you look at this guy, this is the one that was sputtering due to poor drive roll tension. This whole upper edge here that's visible pretty much all the way down, that's all original plate edge. So this has zero root fusion and has no penetration. If you look where it broke, like this black line here, the weld basically just broke on itself there. It wasn't actually, fused to this at all. So this had the lowest numbers. They weren't terrible for the sake of this break test. However, they were lower than the other ones, and really goes to show, if you know something isn't going right, fix it, and be smarter to gouge this out and repair it. So that's not good. Let's go over to this guy. This one was done same settings, just was not sputtering, and we can see same deal here. No penetration or fusion at the start whatsoever. And then about halfway through, the plates got heated up enough to where there is some fusion. You can see that's what we want to see, where you did clear line, no line. This is preferred. That means we had at least some root fusion, if not penetration. This is what you don't want to see. So it's about 50-50. This also posted higher strength numbers, and that is likely why. In the sake of when you bend towards the face, the strength is higher when you have more penetration. And that's simply due to the mechanical advantage that the penetration provides. Now let's look at this. This was preheated plates. When you look here, it still didn't fuse that well in at the start, and that's typical of MIG, and to be honest, of most welding processes. And all of the testing that you hopefully have watched on my channel of stick welding, you'll notice stick tends to do the same exact thing, and that's where the first about ½ inch, 3/4 of an inch of the weld tends to have poorer fusion than the rest of it. And that's typical, and that has to do with the fact that once it gets going welding, that the fusion starts increasing due to the fact the plates are preheating in front of the direction you're traveling. Now there's ways that you can adjust for this, like with stick welding, you can, let me bring this better into focus there for you guys. Sorry about that. You can, with stick, you can turn up hot start a lot to where it boosts the amperage. That helps. With MIG, you can do run-in speed control. You can also just set your settings way hot, and especially on this plate, hotter settings would definitely benefit it. I mean, this is about 195 to 200 amps. Realistically, for 3/8 plate, you'd want a 240 amp MIG welder, and a lot of this would be improved with the additional heat. But for you home hobbyists with your home hobby machines, this is about the best you can expect out of it. And with the preheat, there is more fusion. There is no doubt that, you know, the rough area is only maybe a quarter, a third of it, and then everything else is broken down better when you look at it. And I'll put the worst and the best side by side so you guys can really see what I'm talking about. So again, same settings. You can see how this whole edge got consumed and broke down other than this area. And then this guy, which was done cold with sputtering arc, the whole original plate edge. Stark difference, and that's why this was stronger in this test than this guy. All right, let's go to conclusion. So in conclusion, what did we learn today? Well, we learned a lot, hopefully, at least I did, hopefully you did as well. I will say I'm actually shocked that bending it away from the face did not cause a failure in either of these two welds. That's a very good indication that that weld had bit into the bottom plate and the top plate good enough that it didn't peel the weld clean off of it. Had I ran reduced settings, like had you ran a 140 amp MIG welder on this thick a plate, it probably would have failed drastically because the weld never bit into this plate. Same thing like had I welded over mill scale, that may have played a role as well. And I didn't mention it earlier, and you probably can't see it very well, but that weld, the face of the weld is actually stretched. So looking at this, it is stretched out this way. So that, again, the amount of force it took to bend this like this is a good indication that this weld saw a lot of force and both of them passed. So preheating the plate isn't necessarily going to give you that much more strength if the stress on your weldment is going away from the face. I mean, at least we didn't have a failure here. Now, it does make a huge difference in if the weldment is going to have force bent towards the face. Now again, it all depends on what you're welding as to whether or not any of this matters. And really, by showing you this, I'm just showing you that there's differences depending on how stress gets applied to the weld. And the old adage of, does preheat help? Well, it does, but does it help in all situations? Not necessarily. If you have a very undersized welder and you're trying to weld thick plate, that's your only hope, because I guarantee you, had I welded, like I said, this at 140 amps, or really any of these at 140 amps, and preheat versus no preheat, that it would have been probably double the strength with the preheat, simply because the 140 amp welder has not enough heat to be welding this. Another thing I didn't mention, and I'll show you on this, is that it's kind of common for these things to break at that first like quarter inch to half inch where it kind of peels off the plate. I've seen that extensively with my stick welding tests. And again, it goes to show that if you can carry more heat at the start of a joint, your welds will be stronger. And now this wasn't stick welding, but there are settings that certain MIG welders have that can help boost the heat input at the start to where you get better fusion. Because for the most part, all of these would have fared better with a hotter weld start on them. Same thing like in my stick welding videos. And that's something that I think when I get into TIG weld testing, you're gonna see that with TIG, the fusion is gonna be consistent start to finish, and you're not gonna have any issue with stuff like this. And that's part of the reason why TIG produces such strong welds, is not so much that the wire or the process is stronger than, say, short arc MIG or stick, is just because the process is so prone to having clean welds without defects, such as lack of fusion at the start, that the overall consistency weld to weld is better. And again, I will say I'm pretty impressed that 200 amps on MIG with C25 gas was able to do what it has done here. It has actually exceeded the strength of 1/8 inch 7018 in my testing, which again, it has to do with a bigger weld size, but still, you know, this is better than I would have thought. It's not perfect, and there's obviously lots more testing to be done. So if you got any comments, questions, concerns about this, you know where to leave them. And I would appreciate it if you share this videos with your buddies, and you can also reward me for putting all this effort in to give you guys knowledge. You can reward me by practicing and doing your own tests and becoming better welders yourselves, because that's why I do this, is to help you guys out. So with that said, thanks for sticking around. Until next time.